video is going to show how to use logarithms to solve equations. And they come in very handy when we're trying to solve exponential equations, especially if they're more involved in problems that we've seen previously. I mean, we can always use our calculator to intersect, or use our table and try to find an approximate solution. But if we want an exact answer, then we're going to need a logarithm. So there's this property that we have in logarithms that helps us be able to solve these equations. So let's take a look and see if we can figure out what this property really tells us. We want to put these into our calculator just like we see them. So log of 7 caret 3, and then close the parenthesis, and we find out that that is 2.54 if we approximate it. So approximately 2.54. And if we put in 3 times log of just 7, we get that same thing, 2.54 approximately. Now let's look at this one. Natural log of 6 caret negative 2, close the parenthesis, and we find out that that is approximately negative 3.58. And if we do negative 2 and then ln 6, we get that same thing, negative 3.58. So what do we notice? We notice that in these first two, they both had logs, they both had 7s, and they both had 3s. It's just the 3 that changed. The 3 was in the exponent over here, and it was a coefficient in the second choice. Same thing happened over here with this natural log. We had negative 2 as an exponent in the first one, and then that negative 2 is our coefficient, and now our 6 in our inside our parentheses has no exponent on it. And it looks like the exponent went in front of the log, which is exactly what the power property is. The power property says log base b of x to the n. There's an exponent inside the parentheses. Then that's equivalent to n, that exponent, times the log of base b of just the x. So the exponent comes out front. So how do we use that? Well, we want to isolate the exponential. So we want to get that base all by itself and then move any extra pieces around so that we can get b to the x by itself. And then we want to apply one of our logarithms on our calculator, either the log or the natural log, to both sides. Then we can use that power property to solve for x. And then we can always check our answer by plugging it back in or using the calculator graph or table. So let's look at this first one. 4 to the x. We already have it isolated. The base is, with its exponent, is already isolated by itself, so I'm ready to take the log or the natural log. This time I'll take a log, but it really doesn't matter if we take the log or the natural log. They'll give us the same answer. And then I took the log of 4 to the x, so I have to take the log of 6. That's what it means by taking the log of both sides. And now over here on this side, my exponent is in part of my argument, the log that I'm trying to take. So I can bring it out front, and it becomes x times the log of 4. I've moved that x, so I don't have to write it twice. I'm just writing it in a different place, equal to the log of 6. And if I want to solve for x, this is really that log times that x, so I would divide off the log of 4 and divide off the log of 4 on this side, or divide by the log of 4. So x is going to be equal to the log of 6 divided by the log of 4. Now that is an exact answer. You can leave it at that. This is a perfectly fine answer. This little statement up here says, remember that the log is just a number. So if you don't want to see that log, if that just bothers you and you don't it's harder for you to recognize that as a number, then we can find the decimal. So we take log of 6 exactly like we see it. So I have to have the log of 6 divided by, and then I have to write log again of 4. And when we do that, we get 1.29 approximately. So either one works. And if we just want to double check for ourselves, we can come in here and say 4 to the, if you want to be exact, we would say 4 to the log 6 divided by log 4 So 4 caret, and then parentheses, because we got a division, and literally what I see, log of 6, and then I close that argument, so then divided by the log of 4, and close that argument, and then close the exponent, and I see that that's equal to 6. Now if I had liked the decimal, when I went 4 to the 1.29, it's going to be approximately 6. Let's watch. 4 caret 1.29, and it's 5.979, which is approximately 6. Close enough. So 1.29 works, but if you want the exact answer to come up, then you need to keep it with the log. Right. So here's where I'm headed. I want to get this by itself. That means I need to take the 21 to the other side. So 6 to the x is going to be on this side, and then 21 added to 3 will be 24. Now don't mistakenly think that 6 times 4 is 24, that x is 4. Remember, this is an exponent, 6 to the something. Okay? We know that 6 to the first is 6, and we know that 6 squared is 36. So our answer is actually going to be 1 point something, because it's in between. So let's try and see if we really get that kind of an answer. That's how you can intuitively think about it. So we take the log of both sides, and this side, just to be different, I'm going to take the natural log. So the natural log of 6 to the x is equal to the natural log of 24. And I should put these in parentheses. They don't have to be in parentheses, but when you go to put them in your calculator, you won't forget if you keep carrying the parentheses. All right, the x has to go out in front, because the property says that when I have an exponent in my argument, I can multiply it times the log and take it out of the argument, because it's an exponent times an exponent. That's what we do when we raise a power to a power. So x times ln of 6 is equal to ln of 24. And I divide off the ln 6 so I can get x by itself. So I divide both sides by ln 6, and x is going to be equal to ln 24 divided by ln 6. Okay, what do we do here? Well, we got to, again, we're headed here. So this is the farthest thing away, because it's plus 10. This is right next to it because it's being multiplied. So we're going to take this first. So we still have negative 7 times 0.8 to the x is equal to, subtracting 10 will be minus 8. Then we're going to divide both sides by that negative 7. We're still trying to just get to the base by itself. That's all we're trying to do at this point. So 0.8, or just 0.8 to the x, is equal to a negative divided by a negative is a positive 8 divided by 7. And I would leave it that way, because we can use parentheses to when we take the log of both sides. So don't simplify here. Just leave it just like that. It's so much easier. So we take, and we want an exact answer, so we don't want to round anywhere that we don't have to. Just take the x out front, x times the log of 0.8, remember the x went out front so we don't have to write it again, equal to the log of 8 over 7, so we don't have the exact answer here. Divide both sides by the log of 0.8. So x, oops, I forgot my parentheses, is equal to log of 8 over 7 divided by the log of 0.8, which is approximately, but you don't have to say it. We're good here. But if, again, the log doesn't mean number to you, then you can come into your calculator and say the log of, and it opens a parenthesis for me, so that's why the fraction isn't hard to use at all. 8 divided by 7, close my parenthesis, then divided by log, just like I see it, of 0.8, close the parenthesis, and it's approximately equal to negative 0.598, and I think I'll go out that many decimal places. You could say approximately negative 0.6 if you rounded. And then our last problem here. Now what happens? I'm trying to get to the base all by itself. Well, it is. But look at that exponent. Kind of an interesting exponent. It's not just x, or it's not just, it's got terms in my exponent. That's okay. Property still works. You just have to remember that this x minus 7 has to work all together. So rewriting the problem, t minus 7 is my exponent, so I'm going to write t minus 7, and I'm actually going to put it in parentheses because it's one exponent. It's one piece, so it's in parentheses, groups it together, and then times that log of 3 equal to that log of 65. There's nothing to do over here. It's just a log of a number. Divide the log of 3 so we can get the exponent by itself. So t minus 7, and I really can drop the parentheses now because it's the only thing left on that side, is equal to the log of 65 divided by the log of 3. And the only thing I have to do is get this 7 to the other side. So t is equal to the log of 65 divided by the log of 3. And remember, that is a number. So I have this number that I wanted to add 7 to. I have to add 7 to both sides. And this would be my final answer.